Okay, so in section 3.5, we're going to learn the last type of factoring, which is perfect cubes. So it's similar to perfect square, except this will not involve imaginary numbers, and the formula is a little more complicated to memorize, but we do have a mnemonic device to help you. All right, so we are going to be able to factor the sum of cubes and the difference of cubes. So the way it starts out is you will always have two terms, just like perfect squares, except you'll be able to take the cubed root or split them up into something to the third power and something else to the third power. Okay, so if you can't do it to the second power, then you should be able to do it to the third power, and that will be the difference. Okay, so same thing here, something to the third power and something here. So the way it works is this is what you're going to memorize. I know it looks like a lot, but I'm going to give you some help on how to remember all of it though. So what you'll notice is that the first term is A, and the second term is just B, whatever they cubed, okay? And so both of the formats are the same. You'll notice that the difference is the signs though. So you always start with the first term, the second, with the plus, then you square the first term, you multiply the first and second term together, and then you square the second term. So that's the same in both forms, whether it's a plus or it's the difference. What's different is the signs. So the easiest way to remember the signs is the word soap. Okay? So soap stands for the first sign is the same. See how if you started with the plus, it ends with a plus. If you started with the minus, it starts with a minus. O stands for opposite sign. So because this was a plus, the next one's a minus. If this one's a minus, the next sign's a plus. And then AP stands for always positive. The last term is always positive. Okay? Now, if you've done common factoring first, then you won't be able to factor these terms further. So even though this is a trinomial, it won't factor further if it didn't factor in the beginning, okay? That's not true with perfect squares. All right, so let's try one. So first and foremost, you always want to look for common terms, which this is x, this doesn't have an x, so there's nothing in common. So we are going to split this up. So I need to think of what times what times what gives me x cubed. Well, that's just x. Now, this is really two terms, so I'm going to do the 27. So you can either take the cubed root of 27, or you can think of what times what gives you 27, and it should be the same number. So that's 3. And then y to the 6. This gets a little harder. If you want, you can write out all 6 of them, and then you need to split them up into 3 groups. So you think, oh, well, I need to have 2 in each group. Now, the shortcut is going to be to divide the exponent by 3 because you are splitting them up into 3 equivalent groups. All right, and so this is our A, x, and this is our B. All right, so I'm ready for my final answer of factoring. So the first parenthesis, you just write the first and the second term. So I'm just going to write x, and I'm just going to write the 3y squared. I don't worry about the signs yet. I do that last. In my second parenthesis, I'm going to square the first term, so x squared. Then I'm going to multiply these together. So usually we do alphabetical. So I'm going to put the number first, and then I'm going to put xy squared. And then my last term is I'm going to square the b. So 3 squared is 9. Y squared squared is y to the 4th. Okay? Now I think about the signs. So I think of soap. So same, we started with a minus, so the same means I'm going to keep a minus. O is for opposite, and then always positive. Okay, and so this would be done. All right, let's try another one. So now I have the sum of perfect cubes, because I can't take the square root of 8, and they don't have anything in common, but if I break down 8, and you could do this if you don't want to do the cubed root, or you just don't know the answer, but you could always factor these out. So then I've got 3 2's. So I'm going to think of this as, I'll just use a parenthesis, So 2, and then remember we're going to split this into 3 groups, so I'm thinking b to the 4th. So 2b to the 4th is my a. 125, well, if you're not sure, I know 5 times 25, break that down, and so we've got 3 5s. And there's no letter. So don't think of letters being attached to first or second. Keep them in the same order. So we're ready to factor our answer. So the first term, the second term, then I'm going to square this. So if you want, you can write this out. So if I square that, well, 2 squared is 4. Power to a power, remember you multiply. Then I'm going to multiply these together. So 5 times 2 is 10, b to the 4th. And then the last term is 5 squared. So 5 squared is 25. So let's worry about our signs. So same, opposite, always positive. Now, this is a trinomial, but it will not factor again. All right. Our last problem is